What's up, guys? I'm just going to make a quick video reminding you about systems of linear equations and a couple different ways to solve them. So we're about to do some systems that involve quadratics and linear equations. But before we do that, I just wanted to refresh you on some just solving systems. So basically, when you have a system of equations, you have more than one equation. You're trying to find the values that satisfy both at the same time. So a couple of ways you could do this. First off, substitution. Okay, so this is a prime candidate for substitution because you see y equals 3x plus 2, right? So all you have to do for substitution is isolate any variable you want and plug it in the other one. Since this y is already isolated on this one, you could simply say, since y is 3x plus 2, you come down here to this y, and you could put in that 3x plus 2. You could also, if you wanted to do more work, you could isolate that x and put that up here. You could isolate this y or that x, it doesn't really matter. But so you see how y equals 3x plus 2. If I come down to that bottom equation and I just say, okay, I'm going to put that 3x plus 2 in for that y, what you get is something like this. You see what I'm saying? So that bottom equation, instead of a y, I just put in that 3x plus 2. And the way that helps me is essentially now I just have x's, right? So now I could just solve for x. And once I have x, I could easily find y. So we're going to distribute that 2, right? So if you distribute that 2, this is some basic algebra. You distribute that 2, you get this, right? And what you could do is you can put your right terms together. So 6x plus 1x is 7x, right? Like this. And then you can just subtract that 4 over. So if you subtract the 4 over from both sides, you get 7x is equal to 7. And that gives us an x of what? Gives us an x of 1, right? And now that I have x, all I got to do is go back to the system right here and put in the x either way you want. So I'd probably just put in the top one right there. And if you plug in a 1, you get y equals 3 times 1 plus 2, like that. Just plug in the 1. And 3 times 1 is 3 plus 2 is 5, so y equals 5. So basically, here's what we got. We have a solution of 1 comma 5 because x was 1, y was 5, right? So that should work for both equations. So if you come back up here, right, look at the top one. 3 times 1 is 3 plus 2 is 5, right? Or the bottom one, 1 plus 2 times 5, which is 10. 1 plus 10 is 11. And so what we did there was this called substitution, okay? Now, there's another way you could do these too. Maybe you remember elimination, okay? So elimination works like this. Instead of substituting in for 1, all you have to do with elimination is you basically eliminate one of the variables through basically like addition, and then you solve for the variable. So the one thing that's weird about elimination is these equations need to be quote unquote lined up. So when I say lined up, you gotta have the x's, the y's, the equal sign, and the number, or any order you want to, but they have to be consistent. So you notice that these are not lined up. So what I'm going to do if I want to do elimination is I'm going to take that 3x and just move it over here. So if you simply subtract the 3x from both sides, just some basic subtraction property of equality, you get this, right? So notice the top equation, I just moved the 3x over, right? Now, with elimination, you just want to pick one variable that you want gone, okay? So it doesn't matter which one you do, but let's say I want the x gone, right? Well, if I want the x gone, the top x has a coefficient of -3, right? And the bottom x has a coefficient of 1. So you just want them to be exactly the opposite, okay? So let's say I got a -3 up top, right? The opposite of -3 would be a +3, right? So what you could do is something like this. You could multiply this whole bottom equation by a 3, and if you do that, this top one stays the same, -3x plus y equals 2, but the bottom one becomes 3x plus 6y equals 33. See that? I just multiplied the whole bottom equation by a 3, and now what you'll notice is you got a negative 3x and a positive 3x, right? And if you add those together, they just simply go away. So if I just kind of add these two equations together, right, that goes away. 6y plus 1y is 7y, right, equals 33 plus 2 is 35, right? And if 7y equals 35, you divide by 7, you get y equals 5, just like before, right? Okay. And y equals 5, if I go back up and plug it into either one of these, you're going to get that x equals 1 again, right? So you still end up with the 1 comma 5 as the answer, right? Okay. So that's just a quick refresher on some of the ways you could algebraically solve a linear system. We're going to practice that a little bit today, but one more thing I just want to say, you could take both of those equations and graph them. Take both lines and graph them, and they would cross at the point 1 comma 5. I just don't recommend doing that most of the time, because if they didn't cross on a nice neat point, or if you're a horrible jar like I am and you don't have a sheet of graph paper, it can be kind of hard to see. So I kind of rely on those algebraic methods, but hopefully that refreshes your memory a little bit on solving those systems. We're going to practice that a little bit today before we go on to solving systems with quadratics and linears in them. So I hope you guys enjoy it. Keep up the good work, and I'll talk to you all later.